Okay, I think the majority of people have joined, so let's make a start. Well, good morning to those of you on the West Coast. Good afternoon to those of you joining us from the East Coast. And good evening to anyone joining us from Europe or stations further east. And a very warm welcome to you all. I say a warm welcome, but here in England, it's 5 o'clock in the afternoon. It's cold, it's wet, it's raining, it's windy. The last day of September, and I've turned on the central heating. So thank you for joining this, the 7th of our regular series of short courses on pumping topics. This one's a little longer than the last few. It's going to last about 40 to 45 minutes, but it'll still allow us time for a Q&A session after the presentation. As in previous sessions, we're trying to maintain educational content rather than product placement. And to that end, I did ask another major fire pump manufacturer to contribute, but they prefer not to. So I apologize if this presentation is a little bit Ruhr pumpany, but I have tried to maintain a level of neutrality throughout. We are into session 7 now, and I expect most of you will have attended one or more of the previous sessions. So I will fast forward past the usual 4 or 5 slides that remind you who we are and what we do, and we'll get on straight on with the topic in hand. So let me go back and restart the. There we go. As I say, fast forwarding past these. And this is what we're looking at today. We're going to look at fire pumps in general, but more specifically, the engineered fire pump packages for refineries and offshore oil and gas platforms. You're going to see quite a lot of examples of such packages. We will be holding a Q&A session at the end. With so many attendees, a fully interactive Q&A is impossible. At the last count, there were 220 registered for this one, and we've averaged 200 attendees for all the previous sessions. So it won't be fully interactive, but we'll do the best we can. What I'd ask is that you use the Q&A facility at the bottom of your screen to ask any questions or to make any comments. I'll address those that I can live at the end of the session, and the rest we'll address by mail in the coming days. We are recording this session and we'll make it available to you, to all attendees, as a link to a YouTube video, and we'll also email you a PDF version of the slideshow with my commentary on it as well. So first, NFPA-20, National Fire Protection Association Standard number 20 for the installation of stationary pumps for fire protection. That's the pamphlet you ought to go out and buy. You might also like to consider buying NFPA-13 for sprinkler systems and 22 for water tanks. And if you're really interested, you could get the UL and FM standards that have sprung out of this NFPA-20. So NFPA-20 covers all aspects of a fire pump installation, not just the centrifugal pumps, vertical pumps, positive displacement pumps, but also the controllers, electric drivers, diesel engine drivers, even steam turbine drivers. I've never sold a fire pump driven by a steam turbine, but I'm told there are some out there somewhere. Also testing, performance, maintenance. So it's the full thing. Now, NFPA-20 requires that fire pumps be approved, which means acceptable to the authority having jurisdiction, whatever that might be. If it's an oil and gas installation, it might well be the principal oil and gas, Esso or Shell or Exxon or Mobil. It also requires that they be listed by an organization acceptable to the authority having jurisdiction. And that would be an organization that is concerned with the evaluation of products and which carries out periodic inspection of production and testing of the listed products. Underwriters Laboratories and Factory Mutual are two such listing authorities in the US. They're the main ones. And you'll see that each have their own standards, UL 448 and FM 1311, 12, 13, 19, and 72 for pumps. And they have similar ones for diesel engines and controllers. Now, this is fairly important when it comes to the oil and gas industries, because you guys at the EPCs and consultants will send us various specifications to comply with. But we cannot deviate from the UL and FM standards and still maintain our listed status. So under these circumstances, we can only offer you equipment that would be UL FM if it were not for the requirements of your specifications. So it'd be caveats on that. Firewater pumps. All pumps shall be tested. They shall be dedicated and listed for fire pump service and shall be of these three basic kinds. Now, the major suppliers that are UL-FM approved are Ibarra, Fairbanks Nyhouse, Ruhrpumpen, of course, SPP, Armstrong, Aurora, Patterson, and Koloska. There are a few others as well, but those are the main ones. So NFPA-20 specifies the capacities, 25, 50, 100, etc., going through up to 5,000 gallons a minute at various pressures, generally in the region of 100 to 150 psi. We can go higher, but on case-by-case basis, and there are quite a few out there that are around 7,500 gallons a minute. Among standard pumps, it's 5,000 gallons a minute top. These are the various pump types. The vast majority are horizontal split case. End suction and inline pumps are only for small flows, up to about 200 gallons a minute. Vertical turbine pumps are required whenever there would be a suction lift condition. You cannot use a horizontal split case pump on suction lift per NFPA-20. Package systems are particularly popular now for oil and gas installations in particular, and we will look at several such installations. So looking first at the horizontal split case pumps. Here's the approximate coverage range and pressure range. Now, the standard material for a fire pump would be cast iron, bronze fitted. So that's cast iron casing, bronze wearings, bronze impeller, stainless steel shaft. That will be the standard FM approved UL listed materials. They are available in other materials, but they're not as such UL FM listed in these materials, but they could be on an individual case-by-case basis. A few $1,000s and a few months lead time would be required to elevate a pump to that level. Vertical turbine pumps, as I mentioned before, these are required by NFPA-20 whenever there is a suction lift condition. Again, standard material is cast iron and bronze with steel column pipe, but it can be made in exotic materials for seawater service. Again, and they could be elevated to UL-FM listing, again, for a few $1,000s and a few months on the lead time. Driven through vertical hollow shaft gear drive or vertical hollow shaft motor. Vertical turbine pumps, if you install them in a well or offshore directly in the sea in a stilling tube, then you need to ensure that the minimum water level is 3.2 meters, 10 feet above the second stage impeller. If it goes in a wet pit, you need to ensure that there is 12 inches clearance above the bottom of the pit. Jockey pumps. These are pressure maintenance pumps, usually quite low flows, 5 or 10 gallons a minute. The purpose is to keep the system pressurized and from leakage past the system or somebody opening a valve and letting a little bit of water out, perhaps to wash down something. You don't want your big 1,500 gallon a minute or bigger fire pump kicking in just for that. So you have a jockey pump to keep the system pressurized. There is no requirement for these to be listed. There frequently would be an ANSI pump or possibly a vertical inline pump. Very commonly, it would be a Grundfos segmental ring pump. So although the pump doesn't have to be listed, the control panel does. It needs to have a listed control pump panel. So typical design and installation. The pump supplier will often supply all these auxiliaries, accessories that we show here in red. So obviously the motor is required, the diesel engine, possibly steam turbine. Like I say, I never have done so, but it could be done. Casing relief valve, main flow relief valve. These are commonly supplied by the pump supplier. These, shown in grey, are normally we can supply, but the pump suppliers wouldn't normally supply. They would be accepted as part of a packaged equipment package. The user would probably buy and install these. So these are the accessories here for a horizontal pump, and here much the same thing for a vertical pump. This is a useful slide worth looking at your leisure. It shows a complete fire pump installation, and in it we've referenced the NFPA paragraphs or chapters that apply. So that's quite a useful one for you to look at your leisure. The performance curve. NFPA-20 specifies the rated conditions. So here we have one that's 1,500 gallons a minute, for example, at 150 PSI. It also requires that the shutoff head be no more than 140% of the rated head. So here we've marked the 140% condition, and here you can see it's comfortably less than that. It also requires that the pump will run out to at least 150% of the rated capacity at a head which must be more than 65% of the rated head. So here again is the 150%, 65% condition, and you can see we are comfortably above it. So what NFPA-20 is looking for is a relatively flat curve that will give you a wide operating flow at or near the rated discharge pressure. Now, as I mentioned earlier, you guys are likely to ask us to comply with your client specs, which are going to be API 610 based. Really, API 610 is inappropriate for these services. It's a spec that's designed for handling hot, high pressure, hazardous, flammable hydrocarbons on a continuous basis and operating at or close to BEP, best efficiency point. Fire pumps, on the other hand, are designed as relatively low pressure water pumps designed for standby service, 1 hour a week, and selected to deliver 150% of the rated capacity. The two requirements are mutually exclusive. It's very difficult to select a pump at best efficiency point that will also run out to 150% of rated point. Now, if you send us your API 610 based pump specifications, we will consider and comment on them. But as the basic pump design is to water pump standards rather than API process pump standards, that list of exceptions, comments, and clarifications is likely to be extensive. It'll run to 8 or 10 pages. But that is the nature of the business. That's what we do when we are working with oil and gas companies and major EPCs, major contractors. We try and fit the pumps into the specifications, around the specifications. Okay, the ULFM certification requirements. Not just anyone can supply fire pumps. To get a pump or range of pumps, FM approved and UL listed, requires all of these steps. It's an investment of hundreds of thousands of dollars that we, the pump manufacturers, have spent for our full listed fire pump range. And it's an ongoing expense as well, as we are regularly checked, inspected, and audited by UL and FM. Now, as part of the certification, we are required to assume total package responsibility. So we are responsible for diesel engines and controllers. We take total unit responsibility. So not just any Tom, Dick, or Harry can set themselves up as a pump packager. You're basically limiting yourself to the major fire pump listed companies. Here is the FM approval guide, and here is the UL directory. They are free for you to register. You can register for free and be able to look at any manufacturer to check their listing status. Let me exit this for a moment and go into a new share with okay. And let's have a look for Ruhrpumpen here as a company. Okay, I need to log in again. Look again. Ruhrpumpen, search, and up comes the Ruhrpumpen listing. You see 423 results, and there's a listing of all the pumps that we have FM approved. And the UL guide works in exactly the same way. So this is 443 pumps coming up here. And if you like, let's have a look at another one. Let's have a look at, say, Patterson pumps. Patterson Pump Island, search. And here we see 455 results for them as well, with the full details, flows and pressures. Okay, so if you register, you can do that. You can have a look at all of those. Let me go back into this. There we go, back here. So moving on, fire pump drivers and controllers. Every pump shall have its own dedicated driver. Well, big surprise there. Usually electric motor or diesel engine, which should be sized for the maximum pump power demand. And there are sections in NFPA-20 that refer to motors and diesel drivers. And also, of course, there are the UL and FM standards for those items as well. Motors should be UL listed. This can be a problem if you are going to send us your motor specifications, which might be for a different type of motor. So if it's not a NEMA MG1, NEMA B design UL listed motor, it might well be that we would have to take exception to listing, for example. Vertical pumps have vertical hollow shaft motors with non-reverse ratchets. There's a certification nameplate. Diesel engines, they also should be UL listed, FM approved. There is a requirement within NFPA-20 on the starting system. It requires 2 sets of batteries, each rated for 6 cycles of 15 seconds cranking and 15 seconds rest. And the battery banks alternate. So you have a 15-second start attempt from one, a rest period, then a 15-second start attempt from the other, and then back to the first set, and so on, until you've gone through 6 cycles, 3 from each. Then it would sound an alarm to say the engine's failed to start. And if there's an engineer left around who hasn't already done a runner, he would come and have a look at the fire pump and see what's happened, like the fuel tap supply has been turned off or something, and then he could manually force another set of start attempts. The major UL-FM listed engine suppliers are Caterpillar, Cummins, Clark GM, and various regional manufacturers such as Koloska, Greaves Cotton, they're both in India, Stefco and National Firefighting, they're in the UAE, Bimotor in Italy, and Damas in the Netherlands. I think there are a few more, but that's the majority of them. The diesel tank, it should be, you need 1 diesel tank for each pump. You can't have a common diesel tank. It's sized 1 gallon per engine horsepower. That will nominally give you an 8-hour capacity. And it shall be located above ground level and above the engine's fuel pump. You can't build it into the base plate, for example, and have it on lift. It's an interesting requirement because the engine fuel pumps are perfectly capable of operating in lift, but the specifications clearly say it must be above the center line of the engine pump. These are frequently double wall. If they're not double wall, then you have to have a catchment tank or bund underneath to catch the spillage should somebody drive a forklift truck into it or something like that. Engines can be radiator cooled, but more commonly they're heat exchanger cooled using raw water from the pump in the secondary circuit on a once through system, hence this cooling harness that we show here. On the primary side would be, of course, the engine water and antifreeze mixture, which would be being circulated by the engine pump. Batteries, most commonly onshore, it would be lead acid type. Offshore, it's very frequently nickel cadmium type. And again, as I mentioned before, they have to be sized for the 6 start attempts of 15 seconds each. They would be recharged by the engine alternator, but also by 2 battery chargers inside the control panel. Now, electric starting systems are the most common, but sometimes you get pneumatic starting systems, most commonly as a standby or backup system to the battery system. Even as a secondary system, they still need to be sized for 90 seconds of continuous cranking. So these reservoirs, these accumulators can be very big, and you'll see that later on. Here we show one, and it has a little engine-driven compressor to recharge it. As I said, they're very big, so more common and more popular are hydraulic systems, which are much more manageable from a size viewpoint. And also, in the event of a power failure, an example I would give you, a real example from when I was with Peerless Pump, there was a fire on an offshore platform. They abandoned the rig, and when they went back, the electrics were all down, but there was a hydraulic backup system on the fire pump. So they were able to manually pump it up. There's a pump down here, I think it's there, which you can manually pump. It takes a hell of a long time. It takes about an hour to charge up, and it will take 2 or 3 strong men to do so. But having charged it up, you've then got a fire pump operable, and you can restart your offshore platform. A hydraulic system is much easier to pump up by hand than a pneumatic system. So it has an advantage there as well. Gearboxes for vertical pumps, right angle hollow shaft with a non-reverse ratchet here at the top. They're normally water cooled, either with an external heat exchanger or with a cooling coil. Manufacturers: Amarillo, Duran, Randolph, and Johnson are the main ones. So moving on to controllers. Well, the main suppliers of these are Hubble, that used to be Metron and Elodyne, Tornatech, and many of the pictures you'll see in the coming slides are Tornatech panels. Who else? Firetroll, Master, and Eaton. The motor panels, here's a motor starter. They can be direct online, across the line, you Americans tend to say, star delta, Y delta, and auto transformer start. They are acceptable. You'll see that there's a pressure transducer for auto start on drop of pressure with an adjustable time delay. There's also a solenoid valve for the weekly test start. You would trigger that, it would drop the pressure in the system and thus bring the pump in. Here's the inside of an electric motor controller. You'll see we have remote alarm contacts here. These are the available contacts. And what you'd possibly need is in the gatehouse or in the control room, a remote pump panel so you know what's going on with them. Here's an example where there is an automatic transfer switch as well. That's an option. If you've got 2 electrical supplies, the main electrical supply and the emergency supply, it can automatically switch across to the emergency supply if the main supply fails. Diesel engine controllers. These will control the logic for the start attempts, the 6 start attempts of 3 from each. And again, we have pressure transducer with a time delay. You'd probably want to make sure that the jockey pump had a chance to build up the pressure, and then the electric driven pump before you kick in the diesel driven pump. So again, solenoid valve to initiate the weekly test start. 2 battery controllers, 1 for each one. Remote alarm contacts for these remote alarms, and these are the wiring contacts here at the bottom to the diesel engine. Jockey pump panel. As I mentioned earlier, jockey pumps are not regulated by NFPA-20, but they do need to have a listed jockey pump panel with a pressure transducer to automatically start them. Now, package systems. Excuse me just a second. Most fire pump packages now offer package systems. But not just anybody can supply a fire pump package. You need to be listed for packaging services. And here you can see some of the requirements. And some more of the requirements here. The base plates, the skid type base plates, they can be grouted or ungrouted. These are invariably engineered products. Each one will be different, specific to what you want. Complete pump houses are increasingly popular for oil and gas projects in particular. These housings are frequently flame resistant, fire resistant housings. A typical one might be H60 enclosure, which means it will withstand a hydrocarbon fire for 60 minutes. You also get H120 and H180. In the next 5 slides, we'll illustrate the type of software that pump manufacturers typically supply for some such packages. Here we have one with 2 vertical pumps, one motor-driven pump, one diesel-driven pump. You'll see the inlet fans and the outlet louvers for the air supply. See hatches in the roof to be able to withdraw the pumps. There's another one here, one motor-driven pump, one engine-driven pump, and a jockey pump here. You see all the piping, the internal piping there. Again, the fans, the inlet fans and the outlet louvers. Engine silencer mounted outside the enclosure. Relatively straightforward diesel-driven vertical pump. 2 more similarly. There you see a hydraulic backup start system. And again here. Here's a very big package, yes. So 2 engine sets here on the same skid, and don't know how well you can see this, but it's about 10 tons total weight. So quite a big bugger. Okay, I now have about 40 slides of packaged systems. On each one, where applicable, I will identify some of the highlights, some of the items. I'll go through them fairly quickly so as not to bore you, and also to allow us some time for the Q&A. So here we see a horizontal pump set. It's motor driven and it has a weatherproof enclosure. Sorry, it's an engine driven pump, and it has a weatherproof enclosure over the engine. Now this is required if the pump set is not going in a pump house. It also has NiCad batteries here in the battery box here. Some straightforward pump packages, 5 motor-driven pumps, 5 diesel-driven pumps, and 5 jockey pumps here for Petroleos. Here, a diesel-driven pump, a motor-driven pump in a noise enclosure. There you see the WEG motor, and here with the enclosure, noise enclosure over it. And here's the diesel-driven pump, again with a weatherproof enclosure. And here in this one, we get a good view of the bund or catchment tank that goes underneath the single skinned fuel tank. A pump made of nickel aluminium bronze for seawater service. Note the stainless steel, or it might be duplex stainless piping harness for the engine cooling. Stainless steel control panel here as well. Nice offshore package here. It shows how much equipment we have to get into a small space for an offshore pump. Here on this package, I would like to draw attention here. This is the automatic air release valve. Now, on a vertical pump, when it starts up, the column pipe here, you've probably got 100 feet of column pipe, which is empty when it starts. So you need to, it's full of air. So you need to release that air before the water can flow through into the system. So an automatic air release valve. And here is a nickel aluminium bronze full flow pressure relief valve. 2 jockey pumps on a combined skid. Here's an example where we've got solid shaft motors and a thrust bearing for these, rather than a hollow shaft motor, presumably to meet the customer's motor spec. Stainless steel jockey pump controller. This gives you an idea. 250 horsepower motor, quite a sizable control panel starter for these. They get quite big motor panels. Now here's a pump system with a primary start system, which is electrical start with batteries in these battery boxes here underneath the drive shaft. But here is the pneumatic backup start, and you get some idea of the size of a pneumatic starting system. And that's why they're not quite so popular offshore, just because of this sheer size. And we see the same thing here again. I mean, here is the diesel tank, and beside it there is the air accumulator for the pneumatic start. Again, weatherproof enclosures around the diesel engines. These are some simple, straightforward packages. We've got a jockey pump, we've got a diesel pump, and we've got the main electrical fire pump. The next 3 slides are of NP CAIRO refinery, and of particular interest in this one would be the hydraulic backup start here in a big cabinet on the end. And again, you can see it again here. Not a great picture, but there. Here we have a big pump. It's a 5,000 gallon a minute, and the diesel engine is 825 horsepower. So a big beast. Again, a big skid here with diesel and motor pumps on one big skid. There's a little sidebar here, a trailer mounted pump. Really neat little pump package. Obviously, it doesn't comply with NFPA-20. That's it's a transportable package, this. And here's another trailer-driven pump. This time, I think it has an API 610 process pump here on there, an OH2 pump. So it's probably not even in water service. Another big pump, 6,000 gallons a minute and 1,200 horsepower. Same again. Here's interesting in that you can see here the piping that we supply when it's a package build. Another big vertical pump here, 5,000 gallons a minute and 980 horsepower. And here you can see the noise enclosure around the engine. This package has two diesel-driven pumps in side by side in like a 69 configuration, you might say. See a day tank there, and the two engines side by side. Shame we haven't got a vertical view on this one. There are a 3-pump skid. And here for McDermott, CB&I, this is Kiewit, 3 pumps in one, I think it's an H60 enclosure housing. And there we get a view inside the housing. Here for Aluar Aluminio, motor, diesel and jockey pump in the same housing. And here another two housings, each one with 3 pumps in it. So as you see, each one is very different and they are designed to whatever you want, however you want us to put them together. They're real engineered products. Hydraulic starting system. More the same. Motor, diesel and jockey in the same pump house. Now some simple packages again, straightforward packages. We sold 10 of these to Pemex. And here again, the deviation from the norm, a neat little pair of self-priming pumps. There we go, a 400 gallon a minute package and a 1500 gallon a minute package. Now here we have hazardous area sets. You'll see Artex certified, Zone 1, EXDE, 2C and T4. So we will see on this, especially from the other side, here we go, explosion-proof electrics and control panel, flame traps on the air intakes, purged battery boxes, enclosed exhaust manifold and silencer. Some super duplex pumps that were supplied to Petrobel. Note the pneumatic start again here with the engine-driven compressor to recharge it. Coming towards the end now, KNPC Al Zur refinery. Here's some pump housings. And interestingly, this noise enclosure had a water mist system included inside it. There's a view inside the housing. And here is the water mist system. Okay, well, that pretty much concludes our fun for today. And I just get now to advertise the next of the short courses before we move on to the Q&A. So the next course is on double case pumps, barrel pumps, API BB5 for high pressure applications. 14th of October, that's 2 weeks today. Again, 2 sessions, one for the Eastern Hemisphere and one for the Western Hemisphere. That's you guys. The invitation will be published in probably next week or the week after. Well, it will be published next week, in fact, because it's on in 2 weeks' time. And the next one after that, probably 2 weeks after that, will be on condition monitoring. So put this in your diary. So I'm leaving this meeting open for a little while now to allow you to post in the Q&A box, and I'll endeavour to answer those that only need a short answer here and now. Those that need a fuller answer will be answered in the coming days by email. If you think of something afterwards, email it to info@rawpumpin.com or direct to me, smith@rawpumpin.com. And our marketing team are standing by to direct your questions to the best person. And they also will be sending you, as I mentioned earlier, the link to the YouTube recording of this, this presentation, and a PDF of the slideshow with my commentary on it. If you need a certificate of completion for this short course, drop a line to info@rawpumpin.com. Now let's have a look in the time remaining to us at the Q&A. I see a few people have put into some questions in the Q&A, so let's have a look and see what we've got. Anonymous attendee has said, is there a rule of thumb for jockey pump sizing? Kind of depends on the size of your piping loop, really. It's to cover the leakage, and could well be, say, between 1% and 5% of the fire pump rating would be a good rule of thumb. Is VFD allowed to be installed on the jockey pump? Yes, it is, and it's also allowed to be done on the fire pumps as well. You can have FM approved, UL listed, variable speed, motor driven pumps. Anonymous attendee, could you please add in the slides the name of common firewater pump manufacturers you mentioned at the beginning of the presentation? Yes, that will be in the notes when you see the presentation, the list of all our competitors. Why you would want to go to anybody other than Raw Pumping is beyond me, but I will tell you who they are. Another one from anonymous attendee. Is there any distancing requirements between diesel storage tanks and pumps? No, not that I'm aware of. You've seen on some of those skids, they're quite congested, and the diesel tanks are quite close to each other and quite close to the pumps themselves, very close, in fact. Gary Maguire says, can a large electric fire pump be started using a soft starter or inverter to reduce the inrush current when connected to the main supply or backup generator? Yes, it can. You can use a VFD, or you can have an auto transformer start. You can have a Y delta start. So yes, there are soft start options out there, and they're all FM approved, UL listed. Anonymous attendee has said, at which size of motor and engines is a noise enclosure typically required? There's no rule of thumb. Engines are noisy, and so it's really a matter of whether you're prepared to put up with the noise for 1 hour a week, or whether you need a noise enclosure. Another anonymous attendee, or perhaps the same one, I don't know. If we have electrical power supply with the backup, do we still need to have pneumatic or hydraulic backup start system? You don't need it. NFPA-20 doesn't require that you have a backup system. So it really is down to you. It's a matter of how confident, how comfortable you are. Now remember, you have got 2 sets of batteries. Each set of batteries is good for 6 start attempts. That gives you a total of 12 start attempts. If you can't start the engine within that time, you'll be long gone, I'm sure. But some people prefer the idea of having, like on your trousers, you have a belt and you have a set of suspenders or braces to hold them up as well. You pays your money and you takes your chance. Sagar Sonavane says, can we get NACE material? Moreover, can we get 3 millimeters corrosion allowance or 6 millimeters? Well, if you've got H2S in your water, you're probably supplying the pumps in stainless steel. So you wouldn't have a corrosion allowance on a stainless steel pump. Fire pumps aren't generally available in steel. They tend to move straight from cast iron to stainless steels and duplexes. So yeah, they would be NACE compliant, but they wouldn't have a corrosion allowance. They wouldn't need it. Anonymous attendee says, sealing type, packing versus mechanical seal on split case pumps. Yes, thank you for that. Something I should have mentioned. You can use mechanical seals on fire pumps. It is permissible with FM and UL to have listed pumps with mechanical seals. They have to be separately certified than the ones with packed glands. They're not very common. And the reason is, a fire pump is an intermittent service. It stands idle for 7 days of a week and it runs for an hour. So during that time, the seal faces could dry out, and when a seal faces dry, they can tear when they start up and you could have catastrophic failure. So for this reason, most fire pumps are packed gland, but they can be mechanically sealed. Rienzi Ramsahai, excuse me if I haven't pronounced it properly. Can a fire pump be non-listed? Purely up to you. If the authority having jurisdiction says it's okay to have a non-listed fire pump, and I could see how that would be the case. If you were building a pump set for an oil company and they said, that's okay, we'll accept that this pump is of the type that is ULFM listed, and it would be ULFM listed if we weren't throwing a load of shell specs at you, for example. Ahmed Mezena says, what is the applicable standard for NFPA-20 pumps? Is it ISO or ANSI or vendor standard? It's vendor standard, but it shall comply with the UL standard or the FM standard for that one. So it's based on a water pump standard, but it has to meet the requirements of UL or FM standards that have spun out of NFPA-20. Second question from him is, who is responsible for material selection for the pump casing? That's for the end user to determine, to decide. He's the guy who knows what he's got in his water and therefore will specify. We can suggest, like standard, if it's a regular fresh water, it'll be cast iron bronze fitted. If it's seawater, well, historically, Ni-resist was a very good material for seawater. It's great in static seawater, and a fire pump, of course, is standing still for most of its life. So it's very corrosion resistant in non-moving seawater. So Ni-resist was very popular for many years. Then it moved towards nickel, aluminium, bronze, and that's still a popular choice now. But most recently, people are moving towards duplex and super duplex stainless steels. So they all work. You take your choice. Segar Sonavane has said, do we need positive NPSH margin for end of curve, or till 150% of flow should be enough? Yeah, the requirement is to have NPSH cover at 150% flow, which is effectively the end of the curve. I mean, it might go out to 160 or 170%, but you're covering it out to there. Stephen Rodriguez says, the split case pump on flow 6,000 gallons is UL FM approved. Some people will have a 6,000 gallon a minute UL FM approved pump. I didn't actually look to see if the pump one has one at 6,000. 5,000 is the normal limit according to NFPA-20, but they have done larger ones. I didn't look to see if Rural Pump One has it, but I'm sure some people do have a listed pump, and it certainly could be listed. Anonymous attendee, how far can be the water tank from the fire pump? I don't know the exact figure, if there's one given, sorry. Marco Antonio Padilla, the maximum head rise of the curve is 140%, respecting the nominal head. What is the minimum rise recommended head for fire application? I would say you ought to be looking at probably 10%, especially if you're looking at parallel operation of pumps. If you've got two fire pumps, perhaps that would be operating in parallel, you'd be looking at a 10% head rise minimum. Anonymous attendee again, does NFPA-20 have a specification requirement for an enclosure? Is the enclosure only required for noise or fire protection? Can be either. It could be a noise enclosure, in which case the engine manufacturer will probably have their own standard noise enclosures for their engines. If it's for fire protection, this would normally be a custom built package, and so its end user specifications would normally be coming out with those. They might well have a requirement, as I mentioned, for an H60 or H120 enclosure, which means capable of withstanding a hydrocarbon fire for 60 minutes or 120 minutes, for example. Anonymous attendee, is there any other option for soft start you can place in line on the pump discharge? Not quite sure what this would mean. Maybe you're talking about starting it against closed valve and then opening up the valve, and that wouldn't be acceptable. You've got to be able to immediately get the full flow to the pump as quickly as possible. So auto transformer, Y delta, or an inverter. Diego Cavalos, how does it affect the geographic altitude to electric motor driven pump? How to correct the right power operation at 2,800 meters above sea level? I'm a little out of my depth on electric motors. I don't think that electric motors need derating for elevation. Diesel engines most certainly do, and there is a formula in NFPA for elevation and also for temperature. They get derated. Rienzi Ramsahai again, is there a specific direction of rotation for fire pumps, i.e. clockwise or anti-clockwise? Is this noted somewhere in NFPA-20? Can be either, can be left hand or right hand. Vast majority of engines are right hand rotation, which I think is clockwise. I've got a mental blockage on it at the moment. Most engines only go one way. So that would determine how it happens, but you could have a motor that could go in the opposite direction so that you can put one pump one way and one pump the other way like that. Fire water pumps are usually hydraulic institute design. Yes, that's right. With regards to the capacity, what is the basis of design for the diesel tank? Is it required to be designed for 24-hour continuous runtime? NFPA-20 says 1 gallon per horsepower plus 5% sump and 5% vent. So 110 plus 10% in other words. And that would be approximately 8 hours. It would actually be more than 8 hours, but it's not uncommon on offshore platforms for them to specify 24-hour fuel tank. But NFPA-20 says an 8-hour fuel tank. Hameen Baker says, will there be a recording of this webinar made available? Yes, it will. It'll be sent out next week. This recording will be sent out as a YouTube link, and a slideshow of the presentation that I made with my commentary on the bottom would also be sent to you as a PDF. Gary Maguire says, would there be a preference for 2 diesel-powered fire pumps as opposed to 2 electric pumps with a backup generator? Is it common to have normally dry fire system without a jockey pump that complies with NFPA? Again, you don't need to have a jockey pump, it's just most usual, so that you get instantaneous water availability. Otherwise, it will be a few seconds before the water gets to the end of the sprinkler. Your first question, which was a preference for 2 diesel-powered pumps as opposed to 2 electric pumps with a backup generator. Your choice. Sagar Sonovane says, do we have requirement for minimum circulation flow for these pumps? You'd frequently have a dump valve, a full pressure relief valve. You require them on the diesel pump, but not necessarily on the motor pump. But pumps are designed to run to destruct. Fire pumps, you run them to destruct. You don't mess about with them. You start them, and you've got to get the fire out. So you don't worry much about the minimum continuous flow. And if they're running for during the 1 hour test, you would be diverting the flow through the test line anyway. Hugo Garcia says, what materials are recommended to be used for seawater? I think I just answered that one a couple of questions ago. Sagar Sonovane says, do we have something curves available to do surge analysis? Yeah, surge analysis can be done. Yes, it would be during the contract stage. Yeah. Well, that appears to be all the Q&A. There were 26 of those, but I've got 13 comments in chat. So let me have a look and see if people have asked questions in chat that should have really been in the Q&A. Does NFPA dictate if you can use flexible hose fuel lines from storage tank to engines? I'm pretty sure it says you can't. It will allow you to use flexibles, short length, but not continuous. Sean Beltracchi says, what installations would drive you to having hydraulic starting systems? Just to not need to rely on batteries? Well, yeah, it's belt and braces as well. Julia Mann says, if possible, could you please post noted email addresses in the chat? Yeah, you'll get everyone is going to get the Q&A, the question and answer sessions that I've been doing both this morning and this afternoon. I'm going to transfer them onto an Excel spreadsheet. You will all get a copy of that with the question and the answer. Human Effectari says, are your pump curves available online? Yes, they are. Our pump curve drawing program is available online, and I think virtually all pump suppliers, I'm trying to keep it neutral here, I think other pump suppliers also have their curves all online as well. Jose Luis Mendez says, if there is any preference for the jockey pump type, such as OH1 or OH2, what's your recommendation considering the limitations of OH1s? OH1s are very commonly used, so that's an ANSI pump, are very commonly used for jockey pumps. Grundfos make a multi-stage ring section pump, that's very commonly used for that. But you can also use an API 610 OH2 pump as well. Seems like overkill to me for a pump that is operating very sporadically. Rushi Gandhi says, with regards to the capacity, what's the basis of design for the diesel tank? Okay, I've answered that. It's 8 hours. It's 1 horsepower, 1 gallon per horsepower. And it's not necessary. NFPA-20 doesn't require it to be rated for 24 hours, but some customers might require it. David Pinner says, does NFPA-20 require a 2-pump system, i.e. motor and diesel, or is a 1-pump system allowed to reduce costs? Most commonly, people have one motor, 1 diesel. I think if you have just a motor-driven pump, there would be a requirement that you have an uninterruptible power source as well to be able to switch over automatically to a safe power supply. Yulia Mann says, what is the typical testing available for fire water pumps? Certainly when you're doing engineered fire pumps, you'd have the full range of performance testing, NPSH testing as necessary. But the requirement is that the pump will be tested at its rated condition, at its 150% flow condition, and probably a 5-point performance test. Yulia Mann says, is there guidance for rated flow selection? If we have a complex system with 7 pumps, it's very hard to evaluate allowance by NFPA. Pumps should be sized such that the greatest single demand for any fire protection system connected to the pump is less than or equal to 150% of the rated capacity of the pump. This really is outside of the experience of the pump suppliers to be able to address really. Sorry, I'd be stretching my my knowledge base to answer that one. Well, that seems to be all the chat comments, and that was all the question and answer ones. Anything more in here? Let me just check and see if there's anything more. Yes, there's another one here from an anonymous attendee again. Can diesel and electric fire pumps have the same test flow line returning to the water tank? Yes, I believe they can. I don't think you need 2 separate test lines. So that appears to be all the questions. So just remains for me to say thank you again for attending today. I enjoyed preparing and presenting it. I hope you found it useful. It's taken, oh, we've not done badly. We're only 10 minutes over on the allotted hour. So thank you very much. I hope you enjoyed it. I hope you found it useful. See you on the 14th of October, which is 2 weeks' time, for the next short course. Bye-bye. It's beer o'clock here for me without any question.